In this section, we are going to talk about systems of linear equations in two variables and some applications. Now, a linear equation is defined as, in standard form, as ax plus by is equal to c. So when we talk about a system, we're referring to two or more linear equations existing at the same time. And when you solve, the solution to a system of equations here in two variables would be an order pair. Remember, an order pair must consist of an x value and a y value. So when you solve, you should find the values for both x and y. And this solution must be the solution to each individual equation. It has to be true for both equations. Let's look at this example. Determine if the ordered pair is a solution to the system 6x plus y is equal to negative 2 and 4x minus 3y is equal to 17. So in part A, we have the ordered pair 1/2 and negative 5. 1/2 is your x and negative 5 is your y. To check to see if it is a solution, we're going to substitute these values into each equation to see if they both will work out. So the first equation, we have 6x, so x is now 1/2 plus y is negative 5. And then we want to check to see if it's equal to negative 2. 6 times 1/2 gives you 3. 3 plus a negative 5 gives you a negative 2. So we do get negative 2 is equal to negative 2. So it works for the first equation, but for it to be the solution to the whole system, it has to work for the second equation as well. So let's check the second equation. 4 times x minus 3 times y is negative 5. And we want to check to see if it's equal to 17. 4 times 1/2 gives you 2. Negative 3 times negative 5 is positive 15. 2 plus 15 gives you positive 17. And so we got 17 is equal to 17. So now you can see that this order pair works out for both equations. Therefore, it is the solution to the system. Part B, we have a different order pair. So let's plug 0 in for x and negative 2 in for y. Do both equations to see if it's going to work out. First equation, 6 times 0 plus y is negative 2. We'll see if it's equal to negative 2. 6 times 0 is 0. 0 minus 2 gives you negative 2. Negative 2 is equal to negative 2. So that works out. Second equation, 4 times 0 minus 3 times negative 2. Put a question mark here. 4 times 0 is just 0. Negative 3 times negative 2 is positive 6. So 0 plus positive 6 just give you 6. 6 does not equal 17. So it doesn't work out for the second equation. Therefore, it is not the solution to the whole system. So the answer for this is no. And the answer for the first one is yes. Now the question is, how many solutions can a system of linear equations in two variables have? Well, let's see how many different ways two equations can appear in the same coordinate system. So we all know that the graph for each linear equation is a straight line. So if, say, there are two equations, you should expect to get two straight lines. So let's say this is the first straight line. Second straight line could go like this. So as you can see, they are intersecting at one point. Now, because the order pair that we're looking for, which is the solution to the system, is the one that must work for both equations, must mean that it is a point that belongs to both lines. So therefore, it is the intersecting points here. In this case, you would claim that there's only one solution to the system because there's only one intersection point. Let's look at a second way where two lines can appear. So let's say here's the first line. The second line this time, they're not going to intersect each other, so that means the second line is parallel to the first line. Because they don't share any point, there would be no solution to this system. A third way that two lines can appear, so let's say here's the first line. The second line could easily be a line that is overlapped with the first line. So essentially they are the same line, but maybe being expressed as two different looking equations. So then in that case, because they intersect at infinitely many points, you would say that this one has infinitely many solutions. Okay, so we do have terms for these scenarios. If there is one solution, then you call the system independent. If there's no solution, then we say that the system is inconsistent. And if there are infinitely many solutions, then we say that the system is dependent.